So 10.4 is going to talk about secants and tangents. So a secant is a line that intersects a circle at exactly 2 points, which means in order for that to happen, it's got to go through the circle itself. So it intersects at 2 points, A and B right here. Whereas a tangent is a line that intersects a circle at exactly 1 point. So it's just grazing the circle, and it's intersecting at 1 point, and that 1 point is considered to be the point of tangency. So a tangent line is perpendicular to the radius drawn to the point of contact. If a line is perpendicular to a radius at its outermost point, then it's tangent to that circle. So ultimately what that means is, let's say if I have a circle, here's my radii and it's drawn to a segment out here that's tangent. I can then say that that is perpendicular to the radius. So the tangent is perpendicular to the radius at the point of contact. So Theorem 85, it's called the two tangent theorem, so you can reference it as that. It says if two tangent segments are drawn to a circle from an external point, that is the same external point. So PX is a tangent and PY is a tangent. Then those segments are congruent to each other. So if PX and PY are both tangents that start from the same external point, then you can say that they are congruent to each other. All right, so tangent circles can have two appearances to them. So these are circles that intersect at 1 point. They can be externally tangent. So externally tangent, where they just touch each other at that one location, okay? Or they can be internally tangent, where you have one circle inside of the other. Again, though, they're just touching at that one particular location. Now, it's important to note because sometimes you're going to be given word problems where you're going to have to reference either it being internally or externally tangent. All right, so it says XY, they're common tangents. So it says XY is a common internal tangent to circles P and circle Q at X and Y. XS is tangent to circle P at S, and YT is tangent to circle Q at T. So that is a lot right here to put down in the given. Well, using our two tangent theorem, we have an external point to circle P. So we know that XS is congruent to XY by the two tangent theorem. And if we look at the other circle, we have point Y, which is an external point to circle Q, which means that Y, XY, and YT are congruent to each other. Same reason, so I'm including it in the same statement. Then you have an overlap there. They both have XY in common, so you can use the transitive property to then say that XS is congruent to YT. All right. So I'm going to redraw this one because everything keeps getting cut off here. So we have circle, we have this, and we have this. So we have T, we have O, and P's up here. So it says TP is a tangent to circle O. The radius of O is 8. I'm going to add that in there. Tangent segment TP is 6, and we want to find the length of OP. Well, we know that a radius to a tangent at the point of contact is perpendicular. So I'm going to add my right angle in there. So you can use Pythagorean theorem. So 6 squared plus 8 squared equals OP squared, or x squared. And OP comes out to being 10. Now, there's two types of problems that I love in this particular section. That's example 3 and that's example 4. So with example 3, a lot of times you're not given the picture, so be able to come up with this visual on your own. So it says a circle with a radius of 8 centimeters is externally tangent, okay, to a circle with a radius of 18. So if we're redrawing this, we have two circles. It says they are externally tangent, so they are crossing at one location right here. It says a circle with radius 8 is externally tangent to a circle with radius of 18. So obviously one has to be bigger than the other. So what I'm going to do is I'm going to draw my center point. I'm going to draw one radius, and then I'm going to draw another radius. Okay, now the bigger one has to get the bigger number, so 18, and the smaller one has to get the smaller number. The question is asking us to find the length of the common external tangent. So that is the same segment that is tangent to both circles. So this is your common external tangent. There is your x. So what you want to do is you want to finish the picture or the image. So what I'm going to do is I'm going to connect these dots right here. And this is a radius right here, 18. This is a radius here, which means that that whole segment is equal to 26. But if we look at this figure, we know, first of all, we know that a radius, 18, is perpendicular to a tangent, so I can put a right angle there. I know a radius is perpendicular to a tangent, so I can put a radius there. But I can't put right angles, or a right angle I can't put right angles on the other two sides because the two radii are not perpendicular to each other. So I have to form a rectangle. So what I do is I go to the smaller segment, which is the 8. I take that point and I drag it back to the 18. And now what I'm going to do is I'm going to finish that rectangle. So if this side is 8, this side is 8, which leaves me with 10 left over. If that's a right angle, the one next to it is a right angle. And then if this is a rectangle, we know by properties is that opposite sides are congruent to each other. So if that's x, then we know this is also equal to x. So if I take that triangle right there out of the mix, here's x, here's 10, and the hypotenuse is 26. And you can use Pythagorean theorem to be able to solve for that missing value, which is 24 centimeters for that. All right, but be able to, again, I love these types of problems, be able to come up with that visual on your own and solve it. All right, type 2 that I love are these questions. They're called walk-around questions or walk-around problems. So it says each side of quadrilateral ABCD is tangent to the circle. So I'm actually going to redraw it again, just so you can see how I'm labeling everything. So I have this, and if each segment is going to be, it says each side of the quadrilateral is externally tangent. That means it's just grazing the circle at one location. So here's my thing. So it says AB is 10, BC is 15, AD is 18, and we want to find CD. Okay, so first thing you notice, we've got many two tangent theorems going on here. So from B to here and from B to here, that's two segments that start from the same external point and they're tangent, so they're congruent. And walking around the figure, you're going to find the same theorem is going to hold true, but obviously they're all going to get different marks because they're all going to be different measurements. So now what you have to decide is you have to say, okay, where am I going to start? So let's just say if I label these points just so I have points of reference here, you got to pick a point to start. Doesn't matter where. So let's say I pick BE to be my x. Well, if BE is x, then BH is x. And now I'm going to walk myself around the figure. Well, if I know that BC is 15 and BE is x, well, then EC is 15 minus x. If EC is 15 minus x, then CF is 15 minus x. Then I look and I say, okay, well, I don't know what CD is, so I hit a wall. So now I got to walk my way around the other way. So I go all the way back over here. Now, if BH is x, but I know that AB is equal to 10, that means HA is 10 minus x, which means AG is 10 minus x. And then the other one that we know is that AD is 18. Well, that means GD is 18 minus 10 minus x, and FD is 18 minus 10 minus x. And so I have everything filled in. Now, I'm being asked to get CD. That's what I have to find. Well, here's CD. What's CD made up of? It's made up of 15 minus x and 18 minus 10 minus x. So what I'm going to do is I'm going to add those two together. After I distribute all the negatives, you're going to find the x's actually cancel out. It's not always going to happen that way, but in this case it does. And then you're left with a single number. So that means CD is equal to 23. But the point is you're walking around the figure. You're not jumping around. You got to go either clockwise. Sometimes you hit a wall. You got to go counterclockwise and fill in all the information that you have so you're able to solve for the x and then plug everything back in to figure out all the different measurements.